Imagine getting a birthday card from your grandmother. When you're a kid, the $5 check tucked inside is thrilling. But by the time you reach adulthood, that exact same $5 barely registers. Contrast that with walking down the street and spotting a crumpled $5 bill on the pavement. Finding that money triggers a sudden, undeniable spike in dopamine. This diagram outlines the brain's reaction to surprises. Anticipation and reward structures, these red swirls, fire aggressively for unexpected rewards. Evolutionarily, this is efficient. We dedicate mental resources to surprisingly good or bad events. If expected, the brain doesn't waste energy logging it. This creates a structural challenge for educators. When a learning environment is perfectly consistent and predictable, the brain stops allocating the mental resources needed to reinforce those ideas. Because the situation is solved, the mind begins to deprioritize the information. To snap the brain to attention, we need to intentionally break predictable patterns. Let's say you're walking down the street and see a purple dog. The animal has the right size, shape, and movement to fit your mental category of a dog, but violently violates the rule of color. Psychologists call this cognitive dissonance. Holding two opposing ideas, that this is a dog, but dogs aren't purple, creates immediate mental friction. Your brain becomes uncomfortable and is forced into active problem-solving mode to reconcile the conflicting data. We can trigger this same friction by simply withholding information, creating what researchers call a curiosity gap. It's the exact psychology behind clickbait headlines. By deliberately leaving out a key piece of information, they generate a feeling of deprivation that you feel compelled to resolve. Math teacher Dan Meyer applies this through a philosophy he calls be less helpful. Instead of handing students a complete, structured formula to neatly plug numbers into, he advocates giving them messy, incomplete problems right out of the gate. By holding back the easy answers and leaving intentional gaps in the data, the learner has to actively build their own framework. The struggle to close the gap is what actually solidifies the knowledge. The structure of a problem creates friction, but so does the presence of other people. Years ago, Philip Urey Traceman investigated a mystery at UC Berkeley. Minority math students were failing their courses, while Asian students in identical academic environments were consistently excelling. Traceman dug into the data, ruling out all the standard assumptions. The struggling students worked incredibly hard, had supportive families, and possessed the exact same academic preparation and study habits as their peers. The defining variable was their environment. The struggling students studied in complete isolation, while the successful students worked through problems together in collaborative groups. This collaborative environment introduces social frictions that isolated study lacks. When students work together, they are forced to negotiate different viewpoints, explain concepts to one another, and meet social obligations. These interactions require a much higher level of mental engagement. We are wired as a social species. By introducing a social component to a task, we signal to the brain that the activity is significant and worthy of sustained attention. Friction has a limit. If a problem is too messy, the learner simply becomes overwhelmed and abandons the task. To manage this cognitive load, we have to provide strong visual context. Think about the mental exhaustion of reading a dense block of text explaining right-of-way traffic laws. Contrast that with looking at a simple diagram with arrows showing which car moves first. This chart is the periodic table of elements. It acts as a visual organizer, corralling disparate, complex data points into distinct, color-coded blocks. It gives the learner a way to mentally parse massive amounts of unfamiliar information by essentially building mental shelves in their brain. This graphic uses a conceptual metaphor, breaking down large global demographics into 100 easily countable stick figures. Without this kind of visualization, the human brain struggles to comprehend abstract, massive numbers on any practical level. There is a lingering myth in education that only certain people are visual learners. The reality is that everyone learns visually. Verbal and visual information are processed differently, and failing to use graphics means wasting a massive percentage of your audience's cognitive capacity. In the 19th century, the educator Charlotte Mason argued that bringing the world down to a child's level, making it excessively safe and simple, stunts intellectual growth. True learning is never a passive transfer of data. It requires the brain to actively collide with unexpected, messy information. To capture an audience, you have to engineer that collision. Ask questions that demand real-world application. Deliberately leave obvious details out. Leverage the power of collaborative groups, and use deep visual context to anchor the complexity. In a world overwhelmed with noise, the goal of a designer is not to make information perfectly, predictably digestible. To get attention, you have to engineer the friction that makes the brain hungry for answers.